Hello everyone, welcome to our course Reinforcement Learning. As part of this course, in this lecture we are going to discuss about the foundations of the reinforcement learning. In this lecture, we are going to discuss how evolution of the artificial intelligence and the different types of the learning, machine learning techniques, learning strategies, and different real world applications of reinforcement learning. So this is the content that we are going to discuss in this lecture. So here you can see the question, idea behind reinforcement learning. So you need to understand one thing. Whatever we are implementing as part of the artificial intelligence, everything, most of them are taken from the natural intelligence inspiration. So reinforcement learning also the inspiration from what we are doing during learning phase. In the same strategy, same approach is applied to the machine also. So that is called as the reinforcement learning. For example, you can see here, when a child learns to ride bicycle, does anyone give child thousands of labeled examples? No. When my dad helps me to ride to learn bicycle riding, at starting maybe he holds cycle at starting point. Later he leave the cycle and myself I starts riding the bicycle. So during that learning phase, maybe I fall down, again I get up, again I will try. So this process is repeated. How? Try, make a mistake, get some penalty, you may get some wounds also, but finally we become an expert in the bicycle riding. The same thing will be applicable in the reinforcement learning also. No one will give the thousands of label data. My dad not show more videos to me. So this is how you have to push the pedal. This is how you have to close the brake. This is how you have to slow down when there is feedback is coming. If you are not reducing the speed, you will fall down. He will not demonstrate everything in live. He will not demonstrate. He will not show everything. Just he will guide me at the initial stage. Later, I will understand how to ride the bicycle. When some feedback is coming, what to do? Initially, maybe when the feedback came at the initial days, I may go fast and I fall down. But later I understand. Whenever there is feedback is coming, then I have to slow down. Like that, I understand myself based on my experience to learn the bicycle riding. So same thing is applicable for the machine also. So what strategy applied here? While riding the bicycle, while learning the bicycle riding, first I will try. Definitely I made a mistakes. I fall down. I got some penalties and I got some wounds. But again wake up and again start riding. So this process is repeated, and based on my experience, I learn how to ride the bicycle based on the experience. So during my experience, sometimes I got the penalties, wounds. Sometimes I got the reward. That means riding a bicycle without any issues. Okay, so that thing, what happened generally. But no one gives the thousands of label data to me. No one demonstrate, so this is how you have to slow down. Otherwise, you will fall down when the feedback is coming. No one will demonstrate you. No one will show me in live. I have to experience it everything because there are the multiple scenarios, right? Okay, so that's not possible to explain, to show every scenario while riding the bicycle riding or anything. Later, we are going to update ourselves based on our experience. I think you agree. The same thing is applicable in machine also. So for the machine, so we allow the machine, nothing but allow the AI agent, we allow the robot to try to understand the environment. So during this trial phase, it may got some penalties, when it made a mistake. It may got a reward when it is doing the better work. Finally, based on these penalties and rewards, it will understand how to walk in an environment, right? So let's assume in a particular environment, I allow robot to walk. Then robot at starting don't do anything, so it starts walking. Maybe some obstacle coming. When obstacle come, it fall down. Later it will wake up. Then it understand. So these are the obstacle. So I have to go with some other path. Okay. So when it is going to some other path, then there is no obstacle. So it got some rewards. So like that, it understand the whole environment. So where the obstacles are, where the goal is, where the my task located, everything it understand within the environment, but no one will tell. Just it explain, it experience. Based on the experience, it understand the whole environment. So that robot is a AI agent, is a machine. So machine learn whole environment based on the trial and error. So during the trial and error phase, it made a mistakes, and when it made a mistake, it got the penalties. When the task is fruitful, then it got some rewards. So based on these penalties and rewards, it got some experience how the environment will be, how the robot should work in this environment. It understand everything. Okay, so that's what generally what we are observing in the bicycle riding or human learning. So same thing will be applicable in the machine also. So this type of strategy is called as the reinforcement learning. So reinforcement learning, simply I am saying reinforcement learning means learning of an AI agent in a uncertain environment based on trial and error by receiving some penalties and the rewards based on the experience. It learns the whole environment, and later it will take the decisions because it got experience on that environment. So hope you understand the idea behind reinforcement learning. So coming to the next point. So evolution of the artificial intelligence. So it started in 1950 and currently we are in 2026. So AI is evolved from symbolic AI to expert systems, and then machine learning, and then deep learning, and then reinforcement learning. Currently we are in the generative AI phase. So we are going to discuss about the one by one. Okay, we are going to discuss about the one by one. First, coming to the symbolic AI at the early stage. So symbolic AI means this is an application which was developed based on the rules, based on the logics, based on the symbols. So this represents the knowledge based on the rules and based on the logic and based on the symbols. For example, if red, you stop. If green, go. So some rules and logics will be there, some symbols will be there. So real examples of the symbolic AI are like chess programs, early versions, and rule-based medical diagnosis. So for example, I got a small project from an hospital that they are saying that the number of patients coming to my hospital increasing daily in order to diagnose COVID. So when the people are coming regularly, because of the crowd is increasing, even the particular person don't have a COVID, he may affected with COVID because of the group. So what the task they are asking from me is, they are asking me build some application, a web application or any software application which helps people to diagnose the COVID at home. If that application gives positive, then only they will come to hospital and they will go for the lab tests. Otherwise, no need to come to the hospitals, so that the crowd at the hospital will be reduced. So while giving this task, let us assume they are giving small data, like they are giving the data of the previous patients from previous diagnosis reports, which containing body temperature, oxygen, and their result. So the data showing as, so data is 107, oxygen is 85, and the result showing that COVID positive, and body temperature is 105, and oxygen is 86, and it is also a COVID positive, and 104, and it is a 98, and it is a 0. So different body temperature, oxygen, and 0 means negative, and 1 means positive. 1 means positive. So similarly, some like 101, and here it is something like 88, and here it is a 1, and similarly 98, and it is a 96 oxygen level, it is a 0, and it's like a 97, and here it is a 99, it is 0. Like that, they gave the data completely. So they give this data, they went out. So they're asking me to build an application. So then what I observed is, most of the cases when the body temperature is less than 98, he is a COVID negative person, and if the body temperature is more than 100, so most of the cases it is I observed it is a positive person, COVID positive person. So then I prepared a rule, that is, if body temperature greater than 100, print positive, COVID positive, else print negative, COVID negative. So this is the program I have written. Now front end will maybe looks like this. So body temperature, enter, and here we have the submit button. Okay. So when I enter the submit button like 103 and click on submit button, this backend code will execute. The body temperature is 103, 103 is greater than 100, so it is printed as a positive, COVID positive. Okay. Suppose if I enter the temperature as 99, so 99 is greater than 100? No, it is a false. So else condition will be executed, then it will show it is a negative. Like that I build an application. So this type of AI is called as symbolic AI, because this was developed completely based on the rules. And the rules are prepared by programmer. Rules are prepared by a programmer by himself by observing the data. The rules are prepared by the programmer himself while preparing the rules. Rules prepared by the programmer himself by observing the data. Okay. So this is what symbolic AI is. So coming to these advantages, it is very easy to understand, right? Very easy to understand, easy to implement also. But the limitations are what happened if the programmer, because programmer only building the applications, building the rules. The programmer only building the rules, developing the rules. If the programmer forget one rule, then system completely fail. In this scenario, machines will not learn anything from the data. Programmer see the data, what he thought, based on that thought he prepared the rules, and based on that rules your system will work. System will work. I hope it is clear. Okay, if the programmer forget any particular rule, then the system will be failed. Right? So this is what the symbolic AI is in the early stages. It is the early stages. The case study related to 2020, but I consider this case study for the purpose of explaining the symbolic AI. So hope it is clear. Then now coming to the next one, expert systems. So expert systems means, so researchers thought instead of writing the ordinary rules by the programmer himself, why not collect the knowledge from the experts? Why not collect the knowledge from the experts? Thus expert systems were born. But the same case study. So what I did is, so same case study here. So the hospital people gave the task and they gave this data. Then what I did is, instead of preparing the rules by myself, by the programmer, instead of developing the rules by himself or by herself, what the programmer will do is, he take this data and meet the expert. Who is the expert in this scenario? Because I am trying to diagnose the COVID, healthcare. So now this is part of, so this is the healthcare part. So in the healthcare, who is the expert? The expert is the doctor. So what the programmer will do is, he take the complete data, give it what the hospital people give, the data, along with the data, a programmer met a expert doctor in that domain expert, and they ask, the program will ask to the doctor, so this is the task for me, this is the data, so what are the rules I can frame, how I can prepare a rules, please share your knowledge so that accordingly I will prepare the rules, right? Then maybe doctor may told, so earlier you considered only body temperature and you said that if the body temperature is more than 100, it is a COVID positive, but that is not yet true. See, whatever the case studies I am explaining, it's like a random. Maybe some other features also there, for only easy of explanation purpose I considered all these things. So body temperature is greater than 100, it is a positive you considered. If the less than 100, you said that it is a negative. But it's not a true. The COVID disease not only depending upon the body temperature, at the same time it also depends upon the some other parameters, especially oxygen level also. So you have to consider oxygen level also. So instead of taking only body temperature, you may consider both body temperature and O2 values. You may consider both body temperature and you have to consider the O2 value. So if the body temperature is more than 100 and O2 value is less than 90, there may be a possibility of the COVID. So accordingly you can prepare the rule. Then what I did, then I will prepare the rules as per the inputs from the expert, as per the knowledge from the expert. I prepare the rules. So what he told, so body temperature greater than 100 and oxygen level less than 90, then print positive, else print negative. Like that I prepared a small programming code. Now the front-end application maybe looks like it is asking two parameters, body temperature and O2, and you have the one submit button. So once you enter the body temperature maybe 101 and oxygen level 85, when you click on submit button, then this program will be executed. So 101 greater than 100, 85 less than 90, so then the outcome will be, he will be the COVID positive. It's better to go to the laboratory for the testing. So this is called as the expert system, because we are preparing the rules based on the experts. We are preparing the rules based on the experts' knowledge. Based on the expert knowledge, we are preparing the programmer preparing the knowledge. Programmer preparing the rules. Right? That's why it's called as expert systems. So while preparing the rules, instead of writing the ordinary rules, we collect the knowledge from the experts. We interact with the experts. Then we will prepare the rules. So famous systems are mycin, used for the diagnosis of the bacterial infections. And advantages of expert systems are expert level reasoning. So your rules are somewhat better when compared to your symbolic AI, because you prepare the rules based on the inputs by the expert doctors, and it is useful in the medicine. So problem is, can one doctor know everything? No. So if you met only one doctor, so for some diseases we have to meet the multiple doctors also. So that is also important. So knowledge changes, rules become outdated, so maintenance becomes very difficult. So you have to meet the multiple experts, you have to discuss with multiple people, then you have to prepare the rules. Not only with a particular person or not only with the person who is outdated. If the person is outdated, your rules also outdated. So that is what expert system is. So I hope you understand what mean by the symbolic AI, what mean by the expert system. Okay. So hope you understand these two concepts. In the next lecture, we will discuss about the remaining evolutions of artificial intelligence. So until then, we will meet in the next class. Until then, bye. Thank you.